Good morning, students. In our physics chapter 15 volume 4 we were discussing about some of the important things, that is nothing but principle of superposition of waves, and then we went on to discuss about the reflection of waves, and finally we ended with beats. This completes the theory part of your waves. Now let us move on to the problems, that is nothing but numericals based on the waves. First, before going to the content, I want you to recall these formulas which we have discussed in our theory class. Some of the formulas I am going to list out. Based on this only we are going to discuss the problems. The first formula I am bringing forward is nothing but, we know that velocity is V is equals to W by K. Velocity is equals to W by K, where V is called as velocity. What V is called as velocity. Omega is called as angular frequency. Angular frequency, and K is called as angular wave number. What it is called as angular wave number. And then another formula for velocity I gave is nothing but V is equals to lambda into nu, where lambda is called as wavelength. Where lambda is called as what? Wavelength. And nu is called as frequency. Nu is called as frequency. And then we went on to discuss the formula for W, that is nothing but angular frequency. It is given by 2 pi by T, otherwise it is given by 2 pi nu. Therefore here T is called as time period. What it is called as? Time period. And then we know the formula for frequency of K. Here K is given by 2 pi by lambda, where lambda is called as wavelength and K is called as wave number. And next quantity I am bringing forward is nothing but frequency can be written as reciprocal of time period. All based on this we are going to see the formulas. All these are very simple formulas where you can expect for 3 marks and 5 marks. The first problem I am bringing forward is nothing but, I want you to keep your legend material along with you, which was given in our class. Now coming to the problem, the first problem I am bringing forward is nothing but page number 308. This is page number 308. What is the question I have brought forward here? Page number 308. This is page number. And what is the question number I am going to write here? It is nothing but 1. See the question. What is the question they are given? A bat emits ultrasonic sound of frequency. They are given the frequency. Therefore frequency. First write the given while reading the question itself. Given. What is given here? Frequency. Therefore what is the frequency they are given here? That is equals to 1000 kilohertz. Kilo means how much I said? 10 to the power 3 into 10 to the power 3 hertz. This kilo only I have written it as what? 10 to the power 3. This is your frequency nu. In air, this is where? In air. If the sound meets a water surface, this is nothing but a bat. That bat is emitting the sound waves. That is striking the water surface. When it meets the water surface, what is the wavelength of the reflected? This is bouncing back, we call it as reflected. They are asking you to calculate the wavelength of the reflected. That is wavelength of reflected. I am writing it as REF. LECTED. Wavelength of reflected is question mark. And then transmitted sound. Transmitted means that is entering into the medium. That one we call it as a refracted. What we call it as? Refracted. That wavelength also they are asking. Calculate the wavelength of the reflected as well as the refracted. Again wavelength of refracted is question mark. And then they are given speed of the sound in air. What is the speed of the sound in the air? That is V value they are given in air. Speed of sound in air is 340 meter per second. This is speed of sound in air medium. In which medium it is? Air. And in water, speed of sound in water they are given VW is equals to 1486 meter per second. With all this given, we have to find out the lambda of reflected, lambda of refracted using this given. Now go and find out the formula. What is the formula available to calculate the wavelength? See here you are having the wavelength lambda, here you are having the wavelength lambda. Here velocity is given, frequency is given, you are supposed to find out the wavelength. I am choosing this formula. V is equals to lambda into nu for reflected part. For which part I am going to do here? For reflected part of wave. For reflected part of wave, For reflected part of wave, what is the formula here? V is equals to lambda into nu. Here I need to calculate the lambda. Sending this nu towards this side, then it is V by lambda. This is for what medium? Air medium. Here it is air and this is water. Reflected lies in the air. Therefore, lambda of air, that is nothing but reflected, and velocity of air, and this frequency is in air. Is that clear? Now substitute the given. What is given here? V of air. What is V of air here? 340 meter per second divided by nu. What is the frequency they are given? 1000 into 10 to the power of 3. And it becomes how much? Means it is nothing but, take your calci and start doing the calculation. Let me take out the calci and start doing the calculation. I want you to keep the calculator along with you, so that will be easy. I want you to do the problem along with me. See here how much it is? 340 divided by 1000. How much it is? 0.34 into 10 to the power of plus 3 goes to the numerator, becomes minus 3 meter. So many meters it is in the air. How much it is? 0.34 into 10 to the power of minus 3 meter. I am shifting 1 point. If I shift this point towards your right hand side, then the power will decrease or increase. It will increase by minus 1, and it is minus. This is the wavelength of the reflected wave. Once again I am repeating, very simple problem for reflected part of wave. Reflected means it lies in the air medium itself. This is the velocity of sound in air medium. This is wavelength of reflected, and frequency, that is nu, remains constant. Using this formula I have substituted and I have shifted 1 point towards the right side. Then this is the wavelength. This is all you did for what one? Reflected. Over. Next we have to calculate what? Refracted. Now coming to the refracted part. For a refracted part of wave, same formula. V is equals to lambda into nu. We know that. Now what for medium it is? Refracted. Velocity of sound. Refracted means that is in which medium? Water. Velocity of water. Lambda of refracted. Nu remains constant. Then lambda of refracted is equals to velocity of water. Velocity of wave in water divided by frequency. What is the velocity of water here? 1486 divided by frequency is how much? 1000 into 10 to the power of 3. If you do this, you will get it as 1.86 into 10 to the power of minus 3 meter. What is the value I got here? That is 1486 divided by 1000, and it is 1.86 into 10 to the power of minus 3 meter. If you shift 1 point towards this side, then it is 14.86 into 10 to the power of minus 4 meter. To have a comparison, I made it in the power of 10 to the power of minus 4. This is a refracted and this is reflected. Are you getting? This is very simple problem, which is page number 308, question number 1. Did you understand, students? Keep this formula next to you. I want you to keep this in aside, and legend along with you, along with that calci. I will just say the question numbers. According to the question numbers, we can start solving the problems. Coming to the second problem, that is page number 312, question number 2. Let us discuss. Let me project you the question. Using your legend, I am taking the question here. What is the question I am bringing forward here? A progressive wave travels from medium 1 to medium 2. Therefore, they are given two medium. From that, let me describe here. This is medium 1, this is medium 2. A progressive wave travels from medium 1 to 2. Medium 1 to 2 it is moving. Is that clear? Its wavelength in the two media are given. They are given the wavelength in medium 1 and medium 2. What is the wavelength they are given in medium 1 and medium 2 means? Wavelength in medium 1, it is how much? They are given it as 0.15 meter. 0.15 meter. And in second medium they are given it as 0.2 meter. If the velocity of the wave in medium 1 is 120 meter per second, what is the velocity they are given in this medium means? It is 120 meter per second. What is the velocity of the wave in medium 2, that is V2 is question mark. Also calculate the frequency of the wave, nu is question mark. Once again I am repeating, read the question properly. A progressive wave travels from medium 1 to 2. Its wavelength in the two media are given as, this is lambda 1 and this is lambda 2. If the velocity of the wave in medium 1 is 120 meter per second, that is velocity they have given in medium 1. What is the velocity in medium 2? We have to calculate V2. Also calculate the frequency of the wave. Nu is question mark. This is what they are given. For this, let us consider the formula for medium 1 and medium 2. For medium 1 I am writing. For medium 1. You know that V is equals to lambda into nu. Medium 1, medium 1. Frequency remains constant, so no need to write nu 1. This is for medium 2. Again, we know that V is equals to lambda into nu 2. Velocity is nu 2, lambda is nu 2. See here, lambda 2, V2. Frequency is constant. I am calling it to be equation 1 and I am calling it to be equation 2. Therefore, consider 2 divided by 1. If you consider 2 divided by 1, what happens? V2 is equals to lambda 2 into nu divided by V1 into lambda 1 into nu. Nu gets cancelled. Now I want to calculate V2. Then V2 is equals to lambda 2 by lambda 1 into V1 I am sending to that side, then it comes to the numerator. Then what happens here? Lambda 2. What is the value of lambda 2 here? They are given 0.2 divided by lambda 1. How much they are given? 0.15 into what is the value of V1? They are given 120 meter per second. Use your calculation and calculate here. How much you will be getting there when you do that? See here, point 2 divided by 0.15, and I get it as 1.33 recurring into 120. This is equal to into 120. If I do, then it is 160 meter per second. What is the velocity of sound in that medium? It is 120 meter per second. In medium 1 it was 120, in medium 2 it has become 160. Along with this, they are asking you to calculate the frequency. Now frequency, I said, in both the medium it remains constant. You consider 1, if not you consider 2, you will get the answer. Consider equation 1 or 2, your choice. I am considering 1, that is V1 is equals to lambda 1 into nu. Then I need to find out this frequency, sending lambda 1 towards this side, and it is V1 by lambda 1. What is V1 here? It is 120. What is lambda 1 here? 0.15. If you do this, how much will be your frequency? Means that is 120 divided by 0.15, and you will get it as 800. What is the unit of frequency? Hertz. This is another simple problem based on the given formula. Understood or not? They are given two media. In the two media they are given the wavelength and velocity. In the another medium they are given the wavelength but asking you to calculate the velocity. In both the medium, frequency always remains constant. Keeping that consideration, I have did this first part. This is for second part of the question. Is that clear? Now coming to the next question, go to page number, same page number 312, question number 1. I give it as homework for you. Let me explain the question so that you can do. This is question number 1, page number 312, question number 1. Your hospital uses an ultrasonic scanner to locate tumors in a tissue. They are using the ultrasonic waves. What is the wavelength of the sound in the tissue? They are asking you to calculate the wavelength. Given, let me give the given wavelength they are given. What is the wavelength? Lambda is question mark of the sound in the tissue, in which the speed of the sound. What is the speed of the sound they are given? 1.7 kilometer per second. This is not in SI unit, you have to convert to SI unit. What is the SI unit of velocity? Meter per second, but they are given it as kilometer. We know that kilo means how much I said? 10 to the power of 3 meter per second. This is the velocity they are given. In SI unit I have converted. The operating frequency of the scanner. Frequency they are given. Nu is equals to 4.2 megahertz. Mega means how much I said? 10 to the power of 6 hertz. This is your frequency. Now use the formula V is equals to lambda into nu, and I want you to calculate the lambda. Lambda is equals to V by nu. Just do and let me know. Is that clear? This is homework, very simple. I myself have given the given. I want you to carry this given and do the problem. Is that clear? Going to the next problem. It is going to the page number 312, question number 4. Now let us see the question from the legend. What is the question they are given? Audio frequency range from 20 Hz to 20,000 Hz. They are given two frequency, that is nu 1 is 20 Hz, to where nu 2 is equals to 20 kilohertz. Therefore I am writing the given here. What is given over there means they are given nu 1, that is 20 Hz. From there till from where? It is 20 kilohertz. Kilo means how much I said? 10 to the power of 3 Hz. They are given the two frequencies, nu 1 and nu 2. And they are saying, see here, calculate the range in terms of period. You have to calculate the range, that is in terms of period. That is T1 is question mark and T2 is question mark, from there to there. And then they are asking you to calculate the wavelength. Lambda 1 to lambda 2 is question mark. And then they are asking you to calculate the angular frequency. Angular frequency means that is omega is question mark. 1 to omega 2 is question mark. And given that the wave travels with a speed of 340 meter per second in air, they are given the speed of, that is 340 meter per second. They are given the velocity, or they are given the velocity. Once again I am saying, what is the range of our here to here the sound means, that is from 20 Hz to 20 kilohertz. This is the range. They are asking you to represent this frequency which is given in hertz in terms of time period, in terms of wavelength, in terms of angular frequency. For there they are given the velocity. V is equals to how much? 340 meter per second. Now we know that velocity V is equals to what it is? It is nothing but lambda into nu. Using this formula we can use it for this one to calculate. First they are asking you to express in terms of time period. For time period and frequency, what is the relation? We know that time period T is equals to reciprocal of frequency, that is nu. Using this formula we are going to do for T1, where T1 is equals to 1 by nu 1. Similarly T2 is equals to 1 by nu 2. Then what is here nu 1? 1 by 20. Then 1 by 20 is 0.05. Shifting the points 1, 2, 3 points I am shifting, and it is 50 into 10 to the power of minus 3 seconds. 10 to the power minus 3 is milliseconds. And this is the time period from 50 milliseconds. T2, 1 divided by 20 into 10 to the power of 3. Already I calculated 1 by 20, it is how much? 50 into 10 to the power of minus 3. This plus 3 goes to the numerator, becomes minus 3. Minus 3 minus 3 becomes minus 6. And 50 into 10 to the power of minus 6 seconds. 10 to the power minus 6 I said is nothing but microsecond. Therefore what is the range in terms of time period means, that is from 50 milliseconds to 50 microseconds. This is the time period. First part question is over. Second part is what? Lambda you have to calculate. That one we know that using this formula V is equals to lambda into nu. Therefore where lambda in terms of lambda is equals to V by nu 1. Velocity they are given, that is 340 divided by nu 1 you know, that is 20. 0 0 gets cancelled. 1s are 7s are so many meters. Similarly lambda 2 is equals to V into nu 2, that is 340 divided by 20 into 10 to the power of 3. Already I have done this. How much you got? 17 into 10 to the power of minus 3 meter. That is 17 into 10 to the power minus 3 is millimeter. This is your lambda 2. Then range. What is the range here? 17 meter to 17 millimeter. This is your range. Coming to the last part, that is angular frequency omega. we know that omega is equals to what? 2 pi nu. Then omega 1 nu 1. 2 into 3.14 into 20. 2 into 3.14 into 20. That is, take your calci and start doing it. 2 into 3.14 into 20, that is 125.6 radian per second. Similarly, W2 is equals to 2 pi nu 2, that is 2 into 3.14 into 20 into 10 to the power of 3. Already I have done this. 2 into 3.14, how much you got? 125.6 into 10 to the power of 3 radian per second. This is your omega. Then the range is from W1 to W2. This is your range. Is that clear? Therefore, this is the problems based on what means? Based on, that is, velocity and wave number, all that. Next, before we are discussing the problem based on velocity, wavelength and frequency, let us move on to the equation based method. We have the general expression for the wave. Let us consider this is a wave which is propagated along with the x-axis, and y represents the displacement. What it represents? The displacement, that is positive and as well as negative. And for this we have written the displacement equation as y of x comma t. It is a function of propagation along the x-axis, and time it is given by y of x comma t is equals to a sine kx minus omega t plus phi. Therefore, this is the expression for the displacement of the wave. What it is? The expression for the displacement of the wave, where y is called as displacement along which axis? Displacement along x-axis. This is along the y-axis, and here it is propagating along which axis? X-axis represents the propagation. What it indicates? The propagation of the wave. And then what is here? A represents, means A represents the amplitude. What it represents? The amplitude. That is nothing but maximum displacement. That is maximum displacement along positive x-axis. X-axis, along positive x-axis, we call it as what? Amplitude. And next is nothing but k. K is called as angular wave number. What it is called as? Angular wave number, and its formula is given by k is equals to 2 pi by lambda. This is the formula for the wave number, and its SI unit is radian per meter inverse. This is its SI unit. Keep this thing in the mind. Next, what is omega is called as? Means angular frequency. What it is called as? Angular frequency. That is given by the formula omega is equals to 2 pi nu. Otherwise, I can write it as omega is equals to 2 pi by lambda. There are two formulas available for the frequency. One is angular frequency in terms of frequency, angular frequency in terms of time period, and its SI unit is nothing but radian per second. What it is? Nothing but radian per second. And then what is phi is called as? Means phi is nothing but phase angle. What it is? Nothing but phase angle. Based on this formula, we are going to discuss the problem. I want you to keep this in your mind. If not, take a snap and keep it next to you while solving the problems. And along this, I want you to keep your calci ready and your legend to be ready. Now let us discuss the problem based on this. That is nothing but on the displacement equation. Y of x comma t is equals to a sine kx minus omega t plus phi. That is displacement along y-axis. A for amplitude, k for angular wave number, and formula for wave number is 2 pi by lambda, and angular frequency omega is 2 pi nu or 2 pi by t, and phi is called as phase angle. Based on all this, we are going to discuss the problems. Now let me show you the first problem. Go to page number 312, question number 5. Page number 312, question number 5. This is the question which I am going to bring forward. Just see here. What is the question here I have projected? A harmonic wave traveling in the positive x direction has an amplitude of 1 centimeter. They are given the amplitude. What is the value of amplitude? 1 centimeter, and a wavelength of 10 centimeter, and a wavelength of 10 centimeter. If its speed is 10 meter per second, they are given the speed. What is the speed they are given? 10 meter per second. write the equation describing the wave in the standard form. You have to write the expression describing the wave in the standard form. Once again I am repeating, listen carefully. Here they are given the expression for the displacement, that is a harmonic wave traveling in the positive x direction has an amplitude of 1 centimeter and a wavelength of 10 centimeter. If the speed is 100 meter per second, write the equation describing the wave in the standard form. You have to write the expression for the wave in the standard form. Before going to the content, you have to write down the given. Now, just now I said you what is the question. I am just writing the given from the question. Keep your book along with you. That is page number 312, question number 5. That is what we are going to see now. For this, what is given there? Let us write the given. A harmonic wave traveling in the positive x-axis. This is the expression for positive x-axis. As an amplitude. Amplitude is denoted by what? Amplitude is denoted by small a. Its value is 1 centimeter. Centi means how much I said? 10 to the power of minus 2 meter. Centi means how much it is? 10 to the power minus 2. Therefore, A is equals to 1 into 10 to the power of minus 2 meter. I got it in SI unit. Next, what they are given? A wavelength of 10 centimeter. Wavelength is denoted by lambda. What it is denoted by? Lambda. Lambda value they are given. Lambda is 10 centimeter. Again, 10 into centi can be written as 10 to the power of minus 2 meter. Here 10 into 10 to the power of minus 2. 10 to the power 1 is nothing but 10. Here plus 1, here minus 2. Then it is 1 minus 2 meter. Then it is minus 1 meter. This is the value of wavelength. 10 to the power of minus 1 meter. This is your wavelength. If its speed is, they are given the speed. What is the speed they are given? 100 meter per second. What is the speed they are given? V they are given. Speed 100 meter per second. Describe the wave in the standard form. You have to describe the wave in the standard form. That is y is equals to x comma t is question mark. We have to write this. Is that clear? Now first let me write the expression y of x comma t is equal. It is positive direction. Then a sine kx minus omega t plus phi. This is the standard form of expression. Now for this expression, what are the quantities I require there? Let us see. A is given, no need to worry. Next k is needed. K is not given. We have to find out the k. Then k is question mark. And next omega is needed. Whether omega is given, then omega is question mark. And next what is question mark here? Phi. Phi is not given. Then phi is question mark. Is that clear? Always keep in the mind, if phi is not given, take it to be 0. This is always as per. If pi is not given, take it as 0. This one you have to write. Now I have to calculate the k. What is the formula for k? That is 2 pi by lambda. What is the formula for k? 2 pi by lambda. What is the value? 2 into 3.14 divided by lambda value. How much it is? 10 to the power of minus 1. Use your calci and do here 2 into 3.14. How much will get? 6.28. 6.28 into 10 to the power of minus 1 goes to the numerator, becomes what? Plus 1. 10 to the power 1 is nothing but 1. Then 10 into 6.28 is 62.8 radian per second. This is the value of k. What is the value of k? Is that clear? Next I want you to calculate the omega. What is the formula to calculate omega? Omega is equals to 2 pi nu. Here whether frequency is given, frequency is not given. Then you have to calculate the frequency. What you have to calculate? The frequency. We know that V is equals to lambda into nu. Then nu can be written as what? V by lambda. Am I right or not? This is from the previous problem I am borrowing. Velocity is equals to lambda into frequency. Then frequency is equals to velocity by lambda. In the place of frequency I am going to write that 2 pi. In the place of nu I am going to write it as V by lambda. Already I have calculated 2 pi by lambda. 2 pi by lambda is how much? 62.8. 62.8 into velocity, how much they are given? 100. Then it is, if you do this, how much will you get? 62.8 into 100. Then it is 6280 radian per second. This is the value of omega. This is radian per meter. And this is radian per second. Now all this given I know, substitute in the given formula. That is standard equation. K I got, omega I got, phi I got. If we substitute all this in this, the equation will change to, in the place of y of x comma t, I am substituting here itself for your understanding purpose. A value, what is the value of A? 10 to the power of minus 2 sine k. What is the value of k here? 62.8 x minus, what is the value of omega here? 6280t plus 0. This is the standard form for the wave equation. Is that clear? This is all about the problem based on the given formula. Next, we can go to the next method. One more few problems we can discuss and then we can move on to the next method. Second problem bringing forward, that is nothing but page number 313, question number 6. A progressive wave is described by the equation y is equals to 0.2 sine 50t minus 0.5 x, where x and y are in meter and t is in second. Determine the amplitude, angular frequency, omega, that is angular frequency, wave number and the speed of the wave. All these quantities you have to figure it out. Once again, I am reading the question, page number 313, question number 6. A progressive wave is described by the equation. They are given the equation where x and y are in meter and t is in second. Determine the amplitude, angular frequency, wave number and the speed of the wave. All this quantity you have to calculate. Now, I am going to write the given. Before that, let me put the question number. Page number 313, question number 6. What is the equation they are given? Let me write the given here. The given is nothing but y equal to 0.2 sine omega t, that is 50 t minus 0.5 x, where x and y are in meters. This is for negative x-axis propagation. Negative x-axis propagation means y is equals to a sine omega t minus kx. This is the formula. On comparing with this general thing, I would be getting it as a value. What is in the place of a? What is they are given? 0.2 meter. In the place of omega, what they are given? 50. That is omega is equals to 50 radian per second. T minus minus, in the place of k, what they are given? 0.5 radian per meter. This is all the things I got it from the question. Now what they are asking you to calculate means they are asking you to calculate the amplitude. A is equals to question mark. And then they are asking you to calculate the angular frequency. Omega is question mark. And the wave number. Wave number is denoted by k. And then they are asking you to calculate the frequency. A. On comparing with the general expression A, I got the value of A. Therefore, first job is over. Direct comparison itself, you will get the value of A. Next, you have to calculate the angular frequency. On comparing itself, I got the angular frequency. Omega is over. And then I have to calculate the k, that is wave number. That is also on direct. Only what is left out here, velocity. In the previous problems, I would have given the formula for velocity v is equals to omega by k. Do you remember this? I am getting that thing, that is omega value of substituting 50. K value I am going to substitute, it is nothing but 0.5. Thus, I want you to do it, that is 50 divided by 0.5. Then you will get it as 100. How much it is? 100 meter per second. Therefore, all the four quantities we are calculating. This is direct problem based on the substitution method. Is that clear? Next, going to the next question. That is nothing but page number 313, question number 7. A transverse wave on a stretched string is described by the equation 1.2 sine pi into 2t by 5 minus x by 4, where x and y are in meter and t is in second. Determine the amplitude, wavelength, speed rate, angular frequency, wave number and the speed of the propagation of the wave. Here they are given the standard equation, that is y is equals to 1.2 sine pi into 2t by 5 minus x by 4, where x and y are in centimeter and t is in second. Determine the amplitude, wavelength, period, angular frequency, wave number, and the speed of the propagation of the wave. I have read the question. Using this question, I am going to write the given. Just see here what is given here. I'm going to project the question. Page number 313, question number 7. They are given the equation, that is nothing but the wave equation. What is given here? Y is equals to 1.2 sine pi into 2t by 5 minus x by 4. This is what they are given. Multiplying pi into it, then it is 1.2 sine 2 pi t divided by 5 minus pi by 4 into x. This is what the expression they are given. I am going to compare this with the general formula. General form. If I am going to compare with the general form, this is in negative. Then it is y is equals to a sine omega t minus kx. Comparing with the general formula. This is general form. Once if I compare the place of a, what I will be getting there? 1.2 meter sine. The place of omega, what is left out there? 2 pi by 5. And in the place of t minus, in the place of k, what is left out there? Pi by 4. This is the radian per second, and this is the radian per meter inverse. Therefore, k is equals to pi by 4, x as it is. This is all I got from the given, from the standard form. Now, what are the things they are asking you to find out? Means they are asking you to calculate the amplitude. A is question mark. And next they are asking you to calculate the wavelength. Lambda is question mark. And then they are asking you to calculate the time period. T is question mark. And they are asking you to calculate the angular frequency. That is omega is question mark. And then wave number, k is question mark. And then speed of the propagation of the wave, v is equals to question mark. Now see, from the given, I got the value of a over omega. They are asking you to calculate. Omega I have calculated over k. They are asking you to calculate, that I have got it. Is that clear? Just do the calculation. You will be getting in the exact form. I'll do here. See here, a over next to omega is equals to 2 pi by 5. That is 2 into 3.14 in divided by 5. 2 into 3.14. 2 into 3.14. 6.28. 6.28 divided by 5. Divided by 5. Then it is 1.256 radian per second. I got the value of omega. Next I have to calculate the value of k. K is equals to pi by 4. That is 3.14 divided by 4. 3.14 divided by 4. I want you to do using your calci 785 radian per meter inverse. I got the value of k. I have divided and substituted. That's it. Next, what are the things they are asking you to calculate? They are asking you to calculate the lambda. They are asking you to calculate the time period t, and then they are asking you to calculate the velocity. Is it clear? These are the other things which you have to find it out. Now let us see how to calculate that one by one. Now see here, velocity is given by v is equals to what? Omega by k. What omega by k can be written as? Omega is 1.256 and then k value is 0.785. If you do this, how much you will be getting there? That is 1.256 divided by 0.785. If you do this, you will get it as 1.6 meter per second. I got the velocity also over. Next, what is left out? Lambda is left out, time period is left out. These two things I have to calculate, lambda and time period. You know that k is given by what? 2 pi by lambda. Now I need to calculate the lambda. Whether k value I knew it or not, k value is what? Pi by 4. Then pi by 4 is equals to 2 pi by lambda. Pi gets cancels. Lambda I am sending to this side 4. Then lambda is equals to 2 into 4. 2 4s are 8. therefore it is 8 meter. Lambda also over. Next I have to calculate the time period. We know the formula for omega. Omega is equals to 2 pi by t. Here omega value what they are given? It is 2 pi by 5. And it is 2 pi by t. 2 pi gets cancelled. Taking the reciprocal, then t is equals to 5 seconds. Nothing I have done. I have borrowed the formula, standard formulas, and I have substituted. See here, omega k and a direct comparison I will be getting. And what omega value I have divided and I have written, k value I have divided and written. And then v can be calculated using omega by k. And then I need the value of lambda. K is equals to 2 pi by lambda. And I need the value of time period. Time period is given by what? 2 pi by t. Using all this standard forms I have done here. Is that clear? I give you one problem as homework based on this method. Go to page number 313, question number 7. You see that question. That question is homework for you. Just try to solve it. And next one more question I will give you, which is solved problem. Go to page number 309. Go to page number 309. Page number 313, question number 7 is homework, and page number 309, question number 3 is homework. These two problems I am giving it as homework based on similar method. Based on what? Similar. I want you to solve these two problems. Is that clear? This remains the homework based on today's class method. Next we can go to the next method. Now let us see the problem based on the velocity of a wave in a stretched string, that is nothing but a transverse wave. The expression for that we would have obtained in our derivative class, that is v is equals to square root of t divided by mu. This is nothing but velocity. What it is nothing but velocity of a wave on a stretched string or a transverse wave, where t is called as tension in the string. What it is called as? Tension in the string. And what is mu is called as? Means mu is called as linear mass density. It is called as linear mass density. And its formula is given by mu is equals to mass per unit length. It is nothing but mass of the wire or string, and L is length, but length of the string. Based on this method, let us discuss one problem and then we can move on to the next method which is discussed in your syllabus. Now see here, going to the page number 309. Let us go to the page number 309. What is the question I am going to read here means, this is worked problem. A steel wire has a length of, they are given the length. What is the length they are given? 12 meter and a mass of 2.10 kg. What is the mass they are given? 2.10 kg. What should be the tension in the string so that the speed of a transverse on a wire equals the speed of sound in the dry air at 20 degrees Celsius? It is equals to 343 meter per second. This is what the question they are given. Once again I will read out the question. Page number 309, question number 2. A steel wire has a length. They are given the L value. Mass they are given. What should be the tension in the string wire so that the speed of the transverse wave on the wire equal to the speed of sound in the dry air at 20 degrees Celsius is 343 meter per second. Now using this question I am going to write the given. What is given here? That is nothing but, let us see the given. Question number 2, page number 309. Let us see the problems given. They are given. What they are given means they are given the length of the wire. What is the length of the wire they are given? The length of the wire, it is L. L is equals to 12 meter. And what is the mass of the wire they are given? That is M is equals to 2.10 kg. And then they are saying the velocity, that is V is equals to 343 meter per second. They are asking you to calculate the tension. The formula for tension in the string is, using this formula we have to calculate. To calculate the tension T, I need the value of V. V is given, no need to worry. I need the value of mu. Whether mu is given here? No. Instead of mu, what they are given? Mass by length. Then first calculating the linear mass density. Linear mass density. That is nothing but mu is equals to M by L. What is M here? 2.10 divided by L. What is the value of L here? 12 meters. If you do this, you will get it as 2.10 divided by 12. You will get it as 0.175. 0.175 kg per meter. This is the value of mu. Now we know that velocity v is equals to square root of t divided by mu. Squaring on both sides. Then square means v square is equals to square and root gets cancelled, t by mu. I need to calculate the t, sending this mu towards this side. V square into mu. This is the formula. To calculate mu t, I need v and mu. V is given, mu is given. That's all. Then t is equals to v value 343 the whole square into 0.175. If you do this, how much you will be getting there? You will be getting it as 343 into 343 into 0.175. You will get it as 20,588.57. This is what you will get, and I'm shifting the points and I'm writing here. I'm just shifting 1, 2, 3, 4 points. I'm going to shift towards the left side. Then it is plus 10 to the power 4 Newton. Tension is nothing but force. I got the value of tension in the string. This is the problem based on the speed of a transverse wave on a stretched string. Now let us move on to the next method problem. Now coming to the next problem, that is nothing but speed of sound in the air. We would have obtained the formula using the Laplace correction. V is equals to square root of rho, that is nothing but pressure, into gamma divided by what it is, rho, where P is called as pressure, atmospheric pressure. Nu is called as what? It is nothing but the specific heat ratio. It is specific heat ratio, and nu is called as the density of the air. This is for longitudinal wave. Previous we saw is nothing but transverse wave, where V is called as velocity of the sound. Now let us see one problem based on this method, and then we can move on to the next method problems. Is that clear? Where V is equals to square root of P gamma divided by rho. Going to page number 313, question number 11. Velocity of sound in hydrogen. Here the air is nothing but hydrogen air. At normal temperature, pressure is 1286 meter per second. They are given the velocity. If the ratio of specific heats for hydrogen is 1.41, they are given the ratio of specific heats. Thus it is nothing but 1.41. Calculate the density of the hydrogen at normal temperature pressure. You have to calculate the density of hydrogen. Let me write the given question number, that is page number 313, question number 11. For this, let us discuss the problem. What is the problem they are given? They are given the velocity of the sound in hydrogen, that is V is equals to 1286 meter per second. This is given over here. Velocity is given. If the ratio of specific heat ratio, that is nu, they are given, it was found to be 1.41 for hydrogen, and they are asking you to calculate the density of hydrogen is question mark. Density of hydrogen is question mark. At normal temperature pressure. Temperature pressure means pressure is 1.01 into 10 to the power of 5 Pascal. This is the pressure, 1.01 into 10 to the power of 5 Pascal. This is all given. You have to calculate this density. We know that V is equals to what? Square root of P nu divided by rho. Squaring on both sides. If you square on both sides, what happens? This becomes V square. Square root and square gets cancelled. P gamma by rho. I need to calculate this rho. Send this rho towards this side. Bring this V square towards this side. Rho is equals to P gamma by V square. Then what is the value of P they are given? 1.01 into 10 to the power of 5. What is the value of nu they are given? 1.41 divided by. What is the value of V they are given? 1286 the whole square. If you do this, you will be getting the value of the density. See here, I am just doing here 1.01 into 1.41. If you do this, you will get it as 1.4241 into 10 to the power of 5 as it is, whole divided by. 1286 into 1286. You will get it as 1653796. If you divide this to 1.424 divided by 1653796, you will get it as 0. How many zeros? 0. That is 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 zeros you will get. 1 2 3 4 5 6 0 8 6 1. This is what you will get there. If you divide 1.42 divided by this, you will get it as 0.60861 into 10 to the power of 5. I am going to shift 5 points. 1 2 3 4 5. If I shift to 5 points, how much I will be getting there means 0.0861 into, towards right if I go, it is minus 5 into 10 to the power of plus 5. Plus 5 minus 5 gets cancelled. 0.861 kg per meter cube. This is the value of density of hydrogen. Is that clear? Just direct substitution based on this method. Coming to the last problem, that is based on beads, which we have discussed. This beads is produced by the periodic waxing and waning. Waxing means increase in displacement and amplitude and intensity. What is waning means decrease in intensity, amplitude and displacement. We call it as waning. Therefore, that beat frequency FB is given by what means F1 difference of F2. This is the formula which we have, that is nothing but difference. What it is? Difference. Based on this, they have discussed only one problem in your legend. Going to the page number 311. Page number 311, question number 8. What is the question they are given? 2 tuning forks. How many tuning forks? 2 tuning forks A and B produce 4 beats per second. That is, they are producing 4 beats per second. For 1 second, they are able to produce how many beats? 4 beats. On loading B, that is with wax, that is B is getting waxing, 6 beats per second were heard. If the quantity of wax is reduced, that is for wax is reduced, the number of beats per second again becomes how much? 4. Find the frequency of B if the frequency of A is 256 Hz. Let me explain you the question. That is page number 311, question number 8. What is the question they are given here? They are given 2 tuning fork, that is A and B. This is tuning fork. It will be in a U-shaped clamp. When you strike this, you will hear some frequency. They are having 2 tuning fork, A and B. These two are producing a common frequency, that is beat frequency of how much? 4. Now B, they are doing what? Waxing. When you do waxing, what happens? Its beat is becoming how much? 6 beats per second were heard. If this waxing is reduced, again it becomes how much? 4 beats per second. The beats between them common is 4. If this is waxing, then it becomes 6, again it reduces to 4. If the frequency of A, they are given the frequency of A, that is 256 Hz. They are asking us to find out the frequency of B. This question. We know that beat frequency is given by what? F1 minus F2. If this two difference is how much? 4 beats, then only it is called beats frequency. Now B, FB, I know F1. What is the value of F1? That is nothing but FA minus FB. This difference should be how much? That should be approximately 4 Hz. Now if FA is 256, if you take the difference of these two, then it should be either 4, it should come as 4. Then FB should be how much? Means 256 plus or minus 4 Hz. If you plus that, then it becomes 260 Hz. If you minus that, then you will get it as 252 Hz. This is FB. Either 260 or 252. Therefore, here what I am trying to say means, here possible frequency of B can be two things, 260 Hz and 250. But here it is becoming waxing and then reducing, then it should have maximum frequency. That is 260 Hz is your maximum frequency. Because some wax remains attached to what? B. It is attached some waxing, means that should be greater than this initial frequency. Therefore FB should be greater than FA, because FB is having some waxing. Because of that only it should be greater than the initial value 256. This completes the problem based on the beats, and I want you to practice some more problems which is listed out in the legend. If any doubts is there, you can text me through the WhatsApp. Thank you, students.